This is problem 7-136 from section 7.2.2. We basically have an equation here that's a geometric or exponential equation. So A says before the virus starts erasing, how many bytes of information are on Dennis's hard drive? So basically, what's the starting amount? So if I just look at the equation, I see the number in front of the multiplier is the 500,000 or 5 million. 5 million. Oops. Is the starting value. Okay, basically the number in front of the multiplier. After how many minutes will there be 1,000 bytes of information left? So that's when I have my answer is going to be the 1,000 equals 50,000 or 5 million. Oh man, I'll get it right. Times 1/2 raised to the t. We're going to solve for t. Okay, so first I'm going to divide by 1,000 divided by 5 million. I'm going to get 0.0002. On your calculator, it might come out in, most likely it'll come out in like scientific notation, but hopefully you should be able to change it. If it says 2e to like the -4, that means 2 times 10 to the -4. So it'll be better if you write it out in like decimals. So that's what that becomes. Equals 1/2 to the t power. So I'm going to add a log on both sides so I can get that exponent down. So I'm going to log of 0.0002 equals, I'm going to bring down the t as I'm adding the log to this. Okay. So I'm going to divide both sides by a log of 1/2 to get rid of it. So now I just have this t left. Okay. So if I divide this on my calculator, I'm going to get about 12.3 is t. So that's in about 12.3 years. No, we're not talking about years. We're talking about, let's see, what does it say? Minutes. That's a big difference there. Okay, so 12 minutes until there's only 1,000 left. If it's starting with 5 million, that's a lot going down. Right, the multiplier is 1/2. It's decreasing. It's cut in half every time. So part C says, how long will it be before there's nothing left? Let's just double check how that says. When will the hard drive be completely erased? So that would be when there's 0 bytes left, right? So I'd have 0 equals 5 million. I'm going to do the same like process. Okay, so here's what we would do. We would divide by 5 million, so I'm left with 0 equals this. I'd add a log on both sides. Log of 0 equals a log of 1/2, and then I have the t like in front here. So I'd end up dividing by 1/2. Well, log of 0 is a problem. It doesn't like that. We can never actually get it to equal 0, right? 10 to the what power gives me 0. We've talked about that before. That's not possible if I do it 1/2, or if I do these other numbers that get smaller. Negative makes some fractions, but I'm not going to ever get 0. So this is really not possible to get down to 0 bytes left. So not possible, but equals 0 bytes. But let's get as close as we can. We want to estimate about what time is this going to happen, because it's going to happen at some point. All right, it's going to get smaller and smaller. In mathematical theory, I'm cutting it in half and half and half, and it probably is not ever really technically going to get to 0, but we want to see about what time is it basically nothing left. So let's do this in terms of what if there's 1 byte left. That's pretty close to 0 bytes. So I'm going to set up the same. I'm going to divide by 5 million on both sides, and again, your calculator is probably going to freak out and give you it in scientific notation, but it's going to be 0.0 2, 3, 4, 5, 6 zeros equals 1/2 t, or to the t power. So I'm going to divide, or no, I'm going to add a log to both sides. 1, 2, 3, 4, 5, 6 of them. And I'm going to divide by a log of 1/2 on both sides. Okay, so this time I'm going to get a value. I'm going to get about 22.3 minutes is the time for it takes to get down to 1 byte of stuff on the computer. What are we even talking about here? Bytes of information, okay? So getting to 0, it's not technically possible if it's going to get cut half and half and half every time. But to have under 1 byte, or to have 1 byte of information left, and under that amount is going to take about 22, a little bit, probably after 23 minutes at some point, it's going to be negligible amount of bytes left on this computer. Okay, so I'm going to use my exponential equation and solve for t.